So, in this video, we are going to learn how we can add graphs as parameters to modify geometric shapes. So here, I have a previously defined box shape. I'm going to select the parameter called cut panels to divide the shape into grids. For this, I need to extract surfaces of the shape, and I use dwrap command. Then I connect the surfaces to the input of cut panels. So here, I have a cube geometry divided into pieces. Now I want to use dwrap command again to take the vertices of each divided surface. So these vertices will be the guide for changing the shape that we have. Now to change the shape based on a parameter, I'm going to use list item and connect the list input to the vertices output. And for that, I want to use series command and connect its output to the indices of the list item command. Now let's use the number slider. For example, let's type 50. And copy it 3 times so that we can combine it with the series command. Now we can start seeing the selected vertices when we flatten the list input. So I want to have control over how many vertices are selected when I change the number slider. For that, I'm going to type length and select list length and connect it to the input of the list item command. So now let's type series again to start playing with the position of the vertices. This time, I'm going to connect the length of the list, which will be a number, in our case it's 219, to define the count input of the series. So what I would like to do is to change the position of the selected vertices only. Then they will be linked to the unselected vertices as they used to be in the original shape. And at the end, we are going to see the shape is modified in total. So I want to use replace items command. The list input here will be the original selected vertices. Then the indices input will be the second series list. So to move the selected vertices, I'm going to type vector xyz and connect it to the inputs as well. Let's copy and paste the number sliders as we have created before. Now connect them to the xyz inputs. We can now change the location of them as we want. So finally, I would like to use point deform command. We are going to connect the geometry input to the faces of the original geometry. Now I'm going to connect the points input to the selected vertices at the first place. Let's place the replace list to the final input of the deformation command. If you preview off everything else, we are going to see clearly the deformation. Finally, let's play with XYZ vector inputs, and here we are seeing the change in the geometry. To see it more clearly, we can use custom preview command as always. So from this point, I can start changing if I play with vector xyz. Or play with the series to change the repetition of the selected vertices. Now let's copy and paste the entire script that we just created. Here we can always change the first geometry. For example, I can use sphere this time. As the sphere is only one surface, we may want to increase the division of the surface. So let's type 20 to connect it to the UV number of cut surface. If I check the list item, I can see the number of vertices in the surface. As I want to limit the count of the surface to this number, I'm going to edit it accordingly. So when it comes to vector xyz command, it will be changing the direction of the vertices based on the predefined axis of Grasshopper. Since we are using sphere, the axis of each vertex will depend on their unique position. To get their own axis, I'm going to type dplane. Then I'm going to use amplitude command and connect it to the output of dplane. So from here, I want to define the maximum and minimum of replacement of each vertex. I'm going to use construct domain command, and my minimum domain will be 0 and maximum will be 1. So I'm going to use range command to create a range between 0 to 1. As we can check, it automatically creates a range and we can change it as we want. So I can type 50 to have a range based on this number, but we can see that the result is 51 because the range started from 0. So I'm going to type 49 to have a clear range. Same way, I can increase the number of the range to assign each vertex one unique range to have a more parametric definition. I can connect it to the same number of the series count, but this time I need to subtract 1 to have a right definition. And right now we are going to use a graph for the script, and I'm going to type graph and select graph mapper command. So let's connect the output to the panel to see the movement on each point. Then if I right click on the graph, I can select the type of the graph that I want. Then we can see the changes in the panel. To change the location of each selected point, I'm going to use remap numbers command. After connecting it to the graph, I'm going to connect the source input to the range that we just created. Then I'm going to copy and paste the range script and change the domain to create a different range. After connecting it to the remap numbers, we can clearly see how we increase the numbers in the panel based on the second domain we created. So if you play with the graph, we can keep seeing the change in the panel. Now let's connect the result to amplitude inputs. I will type mass addition as we learned this in the previous sections. We can see that the number is not always as we want, so I'm going to right-click and select graph. Now we can see where we achieved a clear number right as we begin. So now we are ready to connect this first group of script that we copied and pasted. From here, we can change the second domain number to change the size of the shape. Then we can change the step number in the series to better play with the form that we have. We can always reduce the size of the shape, and I can type negative to take the negative number of the domain end. So let's just preview off. Another thing is that I don't want to see the division in the shape at the end. I want to have a whole unique shape. I will use join for the breadths. And I'm going to use subd mesh command because I want to have a more organic form eventually. For that, I need to first turn the breadth into a mesh, and I'm going to use simple mesh command. As usual, I need to flatten the breadth to make them stick together. If I turn the script off and connect the subd mesh to the custom preview, we are going to better understand what I try to do. From here, we can always play with the shape of the graph. We can always reduce the number of the vertices that we want to impact. If I change the number in the step input of the series, the output will continue changing. So, in this way, we can understand how using a graph can help change a predefined form, or how using different inputs in the series can give us different results. Thanks for watching. Let's continue with the other section.